Hi students, under the subject Algebra and Number Theory, we are under Unit 2, Finite Fields and Polynomials. So in that, the topic for discussion is Irreducible and Reducible Polynomials Part 2. This is lecture number 6. So I hope everyone followed up till lecture number 5. So in my previous part 1, I had explained what is a irreducible polynomial and what is a reducible polynomial. So a small brush up, a polynomial which can be written as a product of two polynomials, then of lower powers, then it can be called as a reducible polynomial. If not, it is termed as irreducible polynomials. So there we had seen how to evaluate an irreducible polynomials over the modulo arithmetic, modulo division. So let's get into the PPT. Now let's have the outline here. Outline here, I'm going to just mention few problems under irreducible and reducible polynomials, which will help you to master out the procedure. And next, I'll just give you a small theorem which is called as a reducibility test. So now first problem. So to start up with, I'm starting with a simple problem. I'm taking a polynomial of third degree. F of x is equal to x cube plus x plus 1, which belongs to z2 of x is irreducible. They are asking you whether this is irreducible. Is this polynomial which belongs to z2 of x is irreducible? So how will I handle this problem? It's a very simple problem. So I know what is z2. Z2 is a set which containing two elements, right? It's going to be a field. So the first element is 0 and second element is 1, right? So two elements should be there. So what will I do? How will I find irreducibility? How will I check irreducibility? Roots or whatever it is. After finding out the z, I'll go and substitute this value, every value of that in that particular polynomial and see what is the remainder. If the remainder is 0, then I can call it as a root, and then I can extend that idea to a factor and even for a reducible polynomial. So first I will substitute 0. So if I substitute 0, this will be 0, 0, and the answer I'm getting is 1. So this 1 is not equal to 0, right? This 1 is less than 2, so it cannot be divided. Just put not equal to 0. And second number is 1. So substituting 1 over here, I get 1 plus 1 plus 1. So the answer is 3. So 3 is greater than this 2. So I can divide this 2 over 3, over 2. So the congruence modulo here, the remainder will be 1, which is not equal to 0. So in both cases, for both the elements, okay, I'm getting the answer as your remainder is non-zero. So what my conclusion will be? Therefore 0 and 1 are not roots of f of x. So then f of x is irreducible over z2. Able to follow. So this type of questions you should be able to handle. So first, whatever it is, whenever you see a modular arithmetic, that you declare the set and start substituting those values inside the f of x and see whether the remainder is 0. If the remainder is 0, I can call that as a root. I can make it as a factor. I can even extend that to a reducible or reducible polynomial. So we move on to the next problem. So problem number 2. Now let f of x is equal to x cube plus x square plus x plus 1, which belongs to z2 of x again. Is it reducible or reducible? They are asking us to check and examine. If reducible, find the other factors. Is that clear? So let's check out. So f of x is equal to x cube plus x square plus x plus 1, which belongs to z2 of x. As I mentioned earlier, z2 is a set which contains two elements, 0 and 1. So what do? I substitute 0 first. If I'm going to substitute 0 first, what will I get? 0, 0, 0, 1, which is not equal to 0. So therefore 0 is not a root. Are you able to understand? 0 is not a root in Z2. Now I'll substitute 1. If I substitute 1, my answer is 1 plus 1 plus 1 plus 1 again. So my answer is 4. So is 4 divisible by 2? Yes, it is. So if I'm going to divide this 4 upon 2, my remainder is 2. So I'll be writing 2, 0 of mod 2. So therefore I can declare saying that 1 is a root, or I can also say x minus 1 is a factor. Is that clear? So Now out of out of two elements, I could see that one is not satisfying, one is not a root, and one is it is a root. So from that which is a root, I'm going to derive the factor. Now since they're asking if irreducible, find the other factors they're asking. So you've got to divide that particular polynomial by the factor. That is, factor in the sense can be divided, right? So that number you can put it as g of x here, divisor. So dividing these two, you know how to divide this. This was earlier mentioned, discussed in your lecture number 3 and lecture number 4 about what? Division algorithm. So x cube upon x, you get x square, put x square on the top, multiply it again, change the sign, and keep an eye on the coefficient of the variables. If the coefficient of the variables are greater than 2 of that particular mod, you got to write the remainder. If the remainder is 0, that particular term itself will get vanished. So here I am getting x cube minus x square. Change the sign, cancel it out. Change the sign, cancel it out. So bring down this x and plus 1. Again you are going to divide this x upon x. Your answer will be 1. So put that 1 on the numerator, on the quotient. So take this 1 and multiply. It's going to be x minus 1, which is again changing the sign, you get it as 0. So therefore it's perfectly factorizing it. So this f of x can be written as x minus 1 into this. So how did I get this? This is by division algorithm. Division algorithm says that the dividend, the term, the polynomial which is divided can be written as a product of quotient into the divisor plus the remainder. Since the remainder is 0, we can just omit it. I would understand this particular problem, right? So first, this is a new concept. So first, what do you do? Out of the whatever may be the elements, try to find out the root of that particular polynomial and get the factors out of it. If they are asking you to find the other factors, you got to divide, use that factor as an element and just divide it, and you get the other factors, and you can write as a product of the other factors. So problem number 3. Find two non-zero polynomials f of x and g of x in Z7 of x such that f of x into g of x is not equal to 0. So f of x into g of x is nothing but it is irreducible. So here when you multiply these two, you should not get it as 0. But both should be non-zero polynomials in Z7. So what is Z7? 0, 1, 2, 3, 4, 5 and 6. So what is f of x and g of x? Now you might ask me, there is a big question arising here for the students. How can I write this as 2x square plus 4x plus 1, and how could I write it as x 6x cube? Will it satisfy? Okay, my only concern here is it is absolutely your wish. Your wish saying that you can choose randomly any two polynomials of your kind, right? So that it belongs to Z7, right? These two polynomials should belong to Z7. So always remember, Z7 means what should I do? I should choose numbers less than 7. If I'm going to choose greater than 7, I have to divide, modulo, etc. It is again going to be a tedious process. So what you're going to do, choose a number where the coefficients are less than that particular mod, where things will be easy for you, right? So now what do you do? Why have I chosen x square on one of my polynomial equation and the other as x cube? See, just observe. If I'm going to multiply these two, what will be the coefficient? If I'm going to multiply, I'll be getting, see, they are multiplied here, 2x square plus 4x plus 1 into 6x cube. If I'm going to multiply these two, I'll be landing up with 12x cube plus 24x power 4 plus 6x cube. So now x cube, I cannot separate x cube, right? So it's going to be an odd power. And also 12. 12 if I'm going to divide by 7. Yes, it is not perfectly divisible. In fact, it is one time and the remainder is 5. So I write the remainder here. What is 24? 24 is 21 and remainder is 3. 6 is short of 7. So I'm just writing it as 6x cube. So this is what the answer is. When I multiply these two polynomials, I'm getting a polynomial where the coefficients of the variables are not equal to 0, because we have chosen in such a way. So it is absolutely your thinking coming into, your creativity coming into framing the polynomial equations. So see to that when you are multiplying or when you are dividing or something with a modulo, definitely it should be non-zero. Then only it can be satisfying this particular condition. Therefore, it's not equal to 0. So the next problem will be the contrast of this. You've got to find f of x and g of x, which is equal to 0. So let's see how to do it.